Okay, we're going to talk about significant digits, and you probably learned the rules for significant digits in chemistry, uh, and you can look those rules up online to refresh your memory on those. But I want to go over a method that uh, I find to be pretty simple. Uh, it's called the box and dot method. Maybe you've heard of it, maybe you haven't, but that's the method we use in physics. Box and dot method works simple. In step one, draw a box around all non-zero digits. If there are zeros in the middle, they get included in the box. Step two is identifying whether there's a decimal point. So we draw a box around all zeros after the box in step one. If there's no decimal point, you don't draw a second box. And then step three is just counting up the digits that are boxed in, and they're considered to be significant. So let's do three quick examples. So step one. So let's look at this first one, 504.00. Uh, draw one box around all non-zero digits. So here we go. We're going to draw a box around all non-zero digits. And if there's a zero in there, that gets included. So this zero gets included. If there's a decimal point, there is a decimal point. Draw another box around all zeros after the box in step one. After the box in step one. And then count up the digits that are in the box. They're considered to be significant. So we have 1, 2, 3, 4, 5. 5 significant digits. Second one, box all non-zero digits. Is there a decimal place? No. So we do not draw the second box around these zeros because there's no decimal place. So we only have 3 significant digits. In this problem, the third one, box all non-zeros. Is there a decimal point? Yes. Box all zeros to the right. We've got 5 significant digits. Some more examples. 4,250, box all non-zero digits. Is there a decimal place? No. So this has 3 significant digits. Second one, box all non-zero digits. Box those. There's a decimal point. Box all the zeros to the right. Well, there's no zeros to the right. These don't get boxed in because they're to the left. Okay, so we still only have 4 significant digits. Again, the zeros have to be to the right after the first box when there's a decimal point. Third one, 1, 2, 3, 4, 5. But there's a decimal, so I box this 0 also because it's to the right of the first box. So I've got 6. And you'll start to pick this up pretty easily. That'll be 5. This will be 2. This will be 4 because there's a decimal place. This will be 4, 6. This will be 3. This will be 4. And this last one has 1 significant digit. When you run into something that's in scientific notation, and we're going to talk about scientific notation shortly, uh, then you just consider the number that's there. So how many significant digits does this have? Box. All non-zeros? Well, they're all non-zeros. So 1, 2, 3 significant digit. If this number was 2.05, let's back up. Let's say this number was 70 times 10 to the fifth, then we'd have 1 significant digit. Interestingly, this is not in correct scientific notation form, and we'll talk about that later. But again, if you see it in scientific notation form, just account for the number in front of the multiplication sign.